Hey guys, first of all, thank you very much for all of the support in the last video. I got a lot of subscribers actually, so thank you very much. But let me cut straight to the chase and talk about what I did yesterday and actually 2 days ago and yesterday. So, you know, in the last episode, I explored how to do Atari breakout with reinforcement learning, but all I really did was copy and pasted the code and then understand it afterwards. But I still don't have that macro understanding of reinforcement learning, so that was my objective 2 days ago. And when I explore a field, I always have that initial 2 hours or even a week of just digging through everything that is going on in the field. This always leads me to a macro understanding of the field. So I searched up state-of-the-art algorithms. I looked up Medium articles that talk about the current applications. I looked up big organizations and GitHub projects, right? The most starred GitHub projects probably points at where the field is going. And I saw a lot of stars on the Minecraft reinforcement learning agent, the Doom RL agent, Unity RL agents. So reinforcement learning seems pretty gaming focused right now. And since at this moment I have a little bit more knowledge, I can say that that is true because the benchmark of reinforcement learning algorithms is usually the Atari breakout game. My own learning plan is to implement a few OpenAI Gym projects first. If you don't know what Gym is, Gym makes virtual environments of video games, and we can send actions based on the current state of the game to Gym and receive back the next state and rewards. The state and rewards will be in charge of training the best RL agent, and the reinforcement learning agent will in turn predict the best action based on the current state. So I will implement a few OpenAI Gym projects that maybe get onto more advanced and complex environments like Vizdoom and the Minecraft environments, and then play around with Unity ML agents. At last, I will try to make my own game and train my own RL agent to beat the game. And that's probably going to be done in a Unity environment. And this whole thing looks to span from a week to a month, and we will see about that. So the second day, I implemented the cards pull game from OpenAI Gym. And I'm still trying to implement the Acrobat game. I'll tell you guys about the struggles of implementing the Acrobat game just in a second. In the last episode, again, I actually copy and pasted the code to beat Atari breakouts, and thus I tried to use that code to write my own code for beating cards pull. But a few things were just not right. And most of it is because I am absolutely horrible when it comes to writing functional programming. So anything that has to do with reshaping arrays, expanding dimensions, using a NumPy module, I pretty much suck at. So in Atari breakout, the states were images, right? It was 210 by I think 180 by 3. We feed these images, the states, through a convolutional neural network, and at the end connect it with a dense layer to output 4 numbers, which equals to the number of actions that we can take at a specific time frame. We choose that max number out of those 4 and use that action, and it is because the max number represents the action that will yield the highest potential reward. In cards pull though, I thought that these states were images, right? It kind of makes sense. But I printed out a state that was that I received from OpenAI Gym, and it turned out to be just an array with 4 floats. I still have no idea what the 4 numbers represent, but that quickly changed my game plan, right? I can't feed it through a CNN if I'm only dealing with 4 floats. I at first thought of feeding it through a SVM or regression algorithm and connect it with a dense layer that outputs 2 numbers, because 2 is the number of actions we can take. But I realized that a neural network should work better, even though the other algorithms work better with smaller and feature engineered datasets. Gotta be honest, I just don't know what the 4 floats represent, so I was afraid to use the other methods. I still ended up using someone else's code. The reason being that the Atari breakout code was really bad. It was intuitional to make an agent class that includes methods like get the action and define variables that are shared across the methods and classes within the class and shared across methods. But the Atari breakout code was scattered across the place, and I am too newbie to know what to do. Luckily, the code I found included the had a whole class, and inside the class it included the generation of the model and had methods like get action, stuff like that. So it was really placed and organized. The results were fine implementing this guy's model. You can see right here. Alright, so now on to what I wasn't able to accomplish. This Acrobat game is harder than expected to be. The positive rewards are really hard to get because it only happens when we hit the black line, which requires a fairly low random level of chance to do. And in fact, my model ran for 100 iterations and for 500 time frames each and never reached the black line. And so my model constantly had negative rewards, which intuitively speaking, it kind of gets ignored when too much of the negative rewards piled up. And since the exploration rate is said to be decreasing over time, the model had a lower and lower chance of, ever just randomly hitting that black line. And I really needed that positive reward to guide my model in the right way. Now, I still haven't tuned the exploration and epsilon algorithms, and I think that tuning them will maybe make this work, or maybe tuning the exploration rate so that unless the rewards were ever positive, we always kept the exploration rate at 100% or something like that, right? We can always play around with it. But I looked up the leaderboard of OpenAI Gym, and one of the top guys actually showed that he used a different algorithm than deep Q learning, and he used this thing called a PPO, standing for Proximal Policy Optimization, which I took a peek at, and it is incredibly complicated in terms of its mathematical depth because it also uses something called a TRPO, and that is more complicated. But I would definitely look that into next, and maybe in a few days or a week, you guys will hear back from me about destroying the Acrobat game with PPO and my other progresses in reinforcement learning. Until next time, have a good one.